Okay, so for today's agenda, we're going to talk about what is FeatureScript, how to use a custom feature, some learning resources if you want to learn FeatureScript, which I'm assuming you do since you're on this webinar. And then what we'll take a look at is building a real basic feature, just to explain the code structure and what's going on inside a feature and how to best build it. When we've done that, we'll do an intermediate example and we'll take a look at what a query is. Basically, the query is the building block, if you like, of a successful parametric feature in Onshape. And then we'll go through a little bit more complex and we'll take a look at, I'll make a feature and I'll on purpose make a few mistakes just to show you how you can troubleshoot and work out how to fix any features that you build. Okay, so what is FeatureScript? So FeatureScript is the built-in programming language that the Onshape developers use to build the features that you see in Onshape. So the feature bar that you see at the top here, which you would normally see inside Onshape, every single one of these buttons is powered by FeatureScript. So when you click Extrude, for example, and you get this dialog, the FeatureScript builds the user interface. It also builds the logic. It also builds the feature. So if you've used Onshape to build anything, you've already used a feature or a custom feature, if you like, inside Onshape in FeatureScript. The beauty of it is that it is it is a programming language that we created, but it very closely follows JavaScript notation. So if you've got some kind of JavaScript experience, you're going to find it a little bit easier. If you've got any kind of coding experience, there's a few nuances you need to get familiar with. But once you've got that, the code and how you build code is very similar to anything else. If you've got no coding experience, don't worry. We'll go through some basic examples, and hopefully, I'll try to make it as easy to understand as possible. If I'm losing anyone, please type in a question, let me know, and I'll try to backtrack and explain it in a different way. Okay, just a couple of things to talk about what FeatureScript is and isn't, what it can and cannot do. So FeatureScript is purely for building new part features in a part studio only. So it doesn't work in assemblies, it doesn't work in drawings, part studios only. And essentially, if you can model something in a part studio, you can do it with FeatureScript, because essentially all the features you've used to build that, a feature in your model is using FeatureScript anyway in the background. So all you're doing is modifying the script to do it in a particular order to get the result you're looking for. What it can't do, you cannot modify other features. So you can't have a feature which modifies a fillet somewhere else in the model, for example. You couldn't do that. You also can't do things like export data, rename parts, change colors. Typically, these are done with the Onshape API. Now, the Onshape API is something completely different. And if you're interested in that, it's basically a way to access your Onshape documents through a web connection. So you're not doing it local with FeatureScript, although there isn't actually anything local here because it's all cloud-based, obviously. But if you do it through a REST API, you would need to create a developer account to do that, which is free, and we can talk about how to get onto that if you so wish. Okay, let's take a look at our first feature, and I'll just jump into Onshape just to show a real basic example. Okay, so far we've looked at, here's the standard ribbon within Onshape, but you'll notice that right at the end there is a button called Add Custom Features. Now, basically what it's asking you to do is to add on an existing FeatureScript feature that yourself or somebody else has created, and you can add that to your toolbar. Now, if you go to the Onshape website, let's just have a look at some of these learning resources first. There is under onshape.com/featurescript, and if you forget that URL, it's actually in a link right down the bottom here somewhere. There it is, FeatureScript. So it's kind of a little bit hidden, but you can find it in the footer of every page. This will get you to this page here. And on here, there is a number of learning resources. So you have basically intro video. Then we have a number of features which have been either written by Onshape employees. So for example, I wrote this beams one, this lap joint, the spur gear, Cody did, point pattern, port feature. Fit spline, though, for example, was done by one of our users, as was the airfoil, which is a very nice script. One of the education customers from the UK created this script for creating multitudes of airfoils, so you can do that directly with FeatureScript. Scrolling a little bit further down here, there is a more button. If you expand that, there are some other examples, of doing offset faces, O-rings, end flanges, and again, you can use these to your heart's content. They're free to use, and you can go ahead and do that. A little bit further down this page, there is an overview video of how to start using custom features, which I'll talk about in a moment. And then right down the bottom is some links to more learning resources. So there's Learning FeatureScript, which will take to the FeatureScript documentation. There is a link straight to the forum. If you've got any kind of issues, whether something's not working, you don't understand, please post in the FeatureScript forum. That is monitored all the time, and somebody will get back to you very quickly. And then finally, the very last option here is view the source code. Now, all the code that makes up the features, the standard features inside Onshape, is all open source. So if you wanted to, for example, just modify the extrude feature slightly, you could take our extrude code, make a copy of it, edit it to how you want it to behave, and then that would then be your own custom extrude. So very powerful. It's also, in some ways, it's a quick and easy way to create or learn FeatureScript. In others, it isn't, because of course these features are written by expert developers, so some of the code might be hard to understand if you're not an expert at writing code. Okay, so to use a feature, let's go for the spur gear, for example. Then there's a link there that says use it, so you can click on there. What that will do, it'll open a session of Onshape. If you're not logged in, it will ask you to log in, and then it's basically loaded the feature. So it is a public script. You can see that 60 people have liked this script, so 2,800 documents it's been used in, and the 267 people have made a copy of it. So of those 267 copies, there could be countless of documents it's been used in. So quite a popular script here. Now, there's a button here that says custom features. If you go ahead and click that, it will basically give you this list here. So this is the feature we're looking at, spur gear. Click that, and you get a message saying it's been added to your toolbar. Okay, and that's it. I can close that now. If I go back to my current session, you can see I've now got an icon in the top right corner, SG for spur gear. And when I click that, this is now my custom feature, which I've borrowed, if you like, from somebody else. So it's a public feature. You can go ahead and do this. And this is basically just give you an example of the sorts of things you can do with FeatureScript. Now you can now use the FeatureScript for building geometry, modifying geometry. In this example, it's building a standard part. So there is a number of things. Anything that you want to do with modeling and you want to automate it, and then FeatureScript is the right way to go about it. So for example here, there's logic in here as well. So if I change the number of teeth to 30, it's going to keep the pitch circle diameter the change, but it's going to change the module. Likewise, if I change the module back to 1, it's going to change the pitch circle diameter. So there's logic in there built into the feature. And again, if you look at the code of this, it's one of the features I wrote, and I think I've reasonably commented it, so you might be able to see how this works. And then there's things like, putting in pressure angle. Now, if I put in the wrong size, you can see there you can only enter a value between 12 and 35. So there's logic, and there's filters and tests that you can do within the interface to build the feature exactly, and to prevent people making errors. So let's put that back to 20. And you can see there's all kinds of things in here. Put keyways in, offsets, and so on. So if you put in change that root diameter or something, you can create some crazy results if you so wish. So, the power's in there, and you see how quick it builds it as well. So if you were to try and model that from scratch, or even try to find the correct thing to download it, from a 3D part library somewhere, it would take time to do it. Using this script, it literally takes just a couple of seconds. And with that just being a feature, you could have that as an individual part. You can see here it's now saying it's a spur gear with 30 teeth. You could do that with just an individual part, or you could add an extrusion to it to make it into a shaft with a gear teeth on it. It's whatever you need, whatever you want to do with that. Okay, another way, you don't have to necessarily go to the website to get those features. If you click on the plus button here, you'll basically get a list here. So this will be the same filters that you see on your documents page. So is it features that you've created yourself? And what you'll see as well is that if I go to created by me, it will only show you the documents that have FeatureScript in them. So any features that don't, they will just be grayed out and you can't use them. So once you actually find something, you can click on it, drill down to where the feature is, click on it to add it to your toolbar. Okay, so you can add as many or as few as you like, and if you don't need to use them anymore, essentially every time you log into Onshape, those features will be there. But if you don't want to use them anymore, you can literally right click and remove them. Okay, and I will remove those. And just one quick look under that menu again, you can see there's two options at the top. There's FeatureScript samples. These are features that were written by Onshape employees. These are not meant to be. They've not been fully QA'd and integrated into the products, which is why they don't appear in the toolbar. And also perhaps because they're a little bit more niche type applications. So they wouldn't appear in the main user interface. The other option there, Community Spotlight. These are features that have been created by the community, users of Onshape, and they've put them forward to me to include them in this list. So if you do write some really cool FeatureScript features, please ping me and I'll add them to this list, and then everybody will be able to benefit from it. Okay, well, let's go ahead now and just build a simple feature from scratch. Now, to do this, if you go to the Insert New Element button or the plus icon in the bottom left corner, there's an option there for Create Feature Studio. Now, what the Feature Studio is an IDE, or an integrated development environment, and it's nice because it's actually embedded inside your Onshape document, so you don't have to, have a separate piece of software to actually create the code or compile it or anything like that. It's all done inside your Onshape document. Now, when you first do that, it's going to give you a header. Please don't ever touch that header. That's just automatically generated. The next thing to do, though, there's on this list here, these are a bunch of code snippets to try and reduce the amount of typing that you need to do. So I'm going to build a new feature, so I'm going to hit the new feature button, and that's going to add some code in there for me. Now, the sections that are highlighted are the sections that I need to change. So it's asking for a feature name. So let's call this cube. Then it's asking for so that name cube is what the end user will see. This feature name here is what Onshape uses as a variable. It can be anything as long as it's not a reserved variable, and it'll let you know if you can't use the value that you've chosen. So I'm just going to call this thing my cube for argument's sake. The next section is to define the user interface, and you can do all these from here. So what we're going to ask for, so I'm going to build here a cube where we enter the size of the cube. So what I'm looking for here is a length, or the length that the user will enter. So I'm going to click that, and then it's going to ask me, there's an annotation, and it's going to be, let's see, I'm going to put length of side, something like that. And this is the text that appears in the dialog box when you that you would have seen over and over when using Onshape. The next thing here is a variable name, and we'll look into that in a little bit more detail as to what what that actually means. I'm going to leave it at well, let's just change it to length rather than my length. Okay, and the last thing we'll do here is add some code. This last section is your regeneration code. So anything you put in here is for building features inside Onshape. And there are some code snippets here. So I'm just going to use one of these. So this one, there's one here called fcuboid, which is a feature for automatically building a cube. Ignore all this detail at the moment, and we'll just go ahead and just make a slight modification to this. Now, what you're saying here is that corner one, and you can define a cube by 2 points across the diagonal. That corner one is at 0, 0 inch. Corner 2 is at vector 1 times inch. Okay, so it's basically a 1 inch sided cube that this will generate. But what I actually want is to use this value here. So the value that the user inputs, we're going to put it here. Okay, what we don't want to do, and I'll iterate this a few times during this presentation, is do something like this: definition length times inch. That's an absolute no-no. The reason being, as I'm sure you're aware, when you enter values into an Onshape dialog box, you can change the values on the fly. You have the document units, but then for a length, you could type it in, 5 space millimeter, you can 5 space inch, 5 space meters, feet, or foot, or whatever it is. So the user can override the units of the document. So, and that the units that they specify is all contained within this one variable, and this is called a value with units. Okay, it's not just a number that you might be used to where in normal program it's not just a number, it's a number with a unit assigned to it, because in reality all the units inside Onshape are all in meters anyway. Excuse me. All right, so that's my basic feature. When I'm happy with that, I can press commit or Control S, which essentially saves that feature just to lets Onshape know that it's live, if you like. Now, when I go to my empty part studio, you'll see there is now, under this little icon with the cube inside curly braces, there is now a feature here. Now, I'll say this a few times, but when you are developing your new features, they will, if you're in the same document that you're working on, they will appear under this menu. Anything which appears to the left of that are features which you have linked from somewhere else. Quite a few times users get confused. Perhaps they might have the SpurGear feature loaded into their interface, and then they're modifying the SpurGear feature here, and then suddenly it's got SpurGear written twice. Just bear in mind that anything over here is what is linked from another document. Anything under this menu is live within this document. So just please remember that. Okay, so let's go ahead and add a cube. There it is. There's the sides. If I make it bigger, it goes bigger. If I make it smaller, it goes smaller. Okay, fairly straightforward and fairly quick. So that's really, from its very simplest form, building a feature inside Onshape. So let's go ahead and do something a little bit more complex. Over here is a block with a hole, and say you wanted to say you create this kind of geometry all the time, and your standard operation is to fillet all the edges inside the pocket. Now, if you were to do that manually, you would have to go ahead and pick all these edges, or you could pick the faces. Okay, but you'd have to go around and pick all the faces, which for something simple like this is not a big imposition. But if it's a complex pocket, it's something that you might consider building a standard feature for, or a custom feature, I should say. So let's go ahead and do that. Now, let's create a new feature studio. Now, Onshape has something called a query, and we'll talk about this a lot whilst we're building this feature. So let's call this pocket fillet. If you use 2 words to describe the feature, so pocket fillet, for example, then the icon will say PF on it. Currently, we're not able to create custom icons for your own features. It'll just use the acronym of the name. If you've got pocket fillet feature, it'll still say PF. If you just got pocket, it'll say PO. Okay, so that's just to let you know that. Okay, let's call this, just call it my fillet, for example, for argument's sake. Okay, now then, from a user experience standpoint, what information do we need to know? We need to user to select a face inside the pocket, and we need to know the radius of the fillet that we're going to add. So let's go ahead and add what we call a query parameter. And if you try and follow the Onshape, how we define features, in other words, user interfaces, so the selections are at the top and the values are at the bottom, then it kind of make it a little bit easier for people to follow if you intend to share this feature with other people. So we're going to call this, it is a query. I'm just going to give it a name, and we'll call it pocket face. Now this is the information that Onshape will prompt the user for, and again we'll see that in a minute. It's defaulted here to a type face. We'll look at that in a moment as well. Maximum number of picks 1, and then it creates this something here called a query, and let's just call that face. Now we'll talk about queries more, but a query essentially it's a criterion for finding something in the model. Okay, that's essentially what it is. We'll talk about that in a little bit more detail. Next feature I'll add is a length, because you want a radius, and I'll call that radius. Okay, so that's my user interface defined. If I press commit now, go back to my my Part Studio and select pocket fillet, you see PF on the icon there, then pocket face, which was the value that we put in there, and it'll let me, you can see I can only select one face. If I select another one, it will deselect the previous one because I have a maximum number of picks as 1, and there's the radius. But of course, at this point, it doesn't actually do anything. You know, all we've defined is the user interface. Okay, so let's go back. Let's go back to here, and the regeneration feature that we're going to add is we're going to create a variable. So var, we're going to pick up the faces that are connected to that part, to the face that's been selected. Okay. Notice as well, if there's any kind of errors in your scripts, then you will get a lot of feedback of what's going on, areas which are underlined because it doesn't understand, and essentially because I've not completed the command here. Okay, so what we're going to do, we're going to create a query. Now, one of the nice things about the IDE for FeatureScript is that there are a lot of code snippets. There's a lot of things that will auto-complete. So I'm going to use something called a query. So if I type Q, then it's going to list for me all the queries which are available, and there are quite a few. And really, the only difference is, you know, a query is for finding something in the model. The only difference between all these is different types of things we're looking for. So, you know, there's things, you know, find things that closest to, furthest along, find the largest, find the smallest, these kind of things. But what we want to do is to find, in fact, if I put a next one, QCQ, concave connected faces. So this is basically a built-in query which, given one face, will find all the other faces which are concave to it. Okay, that's simple there. It's now asking for the subquery. The subquery is essentially the face that the user selected. So I'm just going to copy that, paste it into there. So now I have collected all the faces. The next thing to do is to fill it. I can either pull the fillet command from here. In fact, no, I can't because it's not on there. Okay, we'll just type in op, and it'll give me all the op features. Now, an op feature is basically a geometry creation feature. So you'll see there's creating faces, draft, fillets, extrudes, chamfers. Okay, so we're looking for op fillet, and again, just press enter to complete the to auto complete, and it's asking for two things. First of all, the entities to fillet and the radius of the fillet. Okay, so the entities to fillet are these faces. So I'm going to copy that and paste it here. The radius, remember, we don't want to have inch in there, so the radius is definition.radius. Okay, and then we'll go ahead and commit that. Okay, and now when I go ahead and build this pocket fillet, asking for a pocket face, let's go ahead and put in a smaller value there, click in there, and there it's done. So you can see the power of that is very powerful indeed. Okay, we've got a question. Is it possible to organize different feature groups and group them like on a folder or tree? I'm assuming you mean in the user interface. No, there isn't. I mean, you see these standard features here. The order and the customization of that is not possible. It's on a list of things to do, but it's not been given such a highest priority. Okay, what I will do actually is I'm just going to go back to the presentation, and which I should have done this before I jumped into that, just to explain a little bit more of what's going on. So this was the code for the cube, which I created a short while ago. And what we'll see is, just looking at these, is that first of all, those first two lines are auto-generated. Like I mentioned, please don't modify those. This here is the feature definition. You have the user interface and variable definition, which we talked about, and then you've got the feature regeneration code. Okay, but one thing I wanted to point out in the feature definition is what these variables at the top here are called. So you've got context, ID, and definition. We've seen definition a few times already, which is why I should have talked about this first. Okay, so a context, that is just the internal name that we use for a part studio. So whenever you do something to the part studio, you have to pass the function the context, or say, this is the part studio I'm working on. So, this is so Onshape knows what to do. The next feature, or the next thing, is the ID. Now, the ID is the feature identification number. Every feature in a part studio and every element, so every point, line, arc, face, solid, surface, everything's got a unique ID. And it has to be unique in order to get a fully parametric system with associativity, so that as you build features, they know what they should be modifying. Okay, and the last thing is this definition, which is a variable of type map, and this is really what I should have explained first. So a map, if you like, is a container which can hold as much information as you like. You can put extra information in there as you want. You're not limited to what goes in there. And essentially, it's organized in what we call key value pairs. So you would give something a name, like radius, and the value, what that radius would be. So definition.radius, you can see here, you can specify by giving it a key name. So that will be definition.radius equals a value. Will assign the that key value pair in that feature, in that definition. Or if you do just definition.radius, it will retrieve the value if there is a value there already. Just to let you know that, of course, that if there's no value defined, you will get this thing called undefined, which you can test for while you're troubleshooting. Duplicate keys are not allowed, and you can do either of these two notations, whichever you prefer. Okay, let's, like I say, I should have done that a little bit earlier, but let's jump back to this model here. Now, what you'll see here is, of course, it's built this pocket fillet feature here. Let me just go ahead and delete that and create that again. So I'm going to create pocket fillet. Now what you'll see here is that the default value is 25. Now that is the value which is taken from the when you create an extrude, the default value is 25. So that is what Onshape is using there for the radius. If I go ahead and click this this pocket, nothing happens. Okay, why isn't anything happening? Well, the feature's gone red. If I hover over it, failed to fillet selections. Okay, it's not the most informative error message, but that is the error message that Onshape has thrown back to us from the op fillet command. Okay, and what you actually find is that as you modify, as you make it smaller, it's going to work. So you can see that clearly the fillet isn't working because it's too big. Okay, so how can we fix that? Looking back at this code, you'll see here there is a filter or a check on the input, if you like, and it's called isLength. So it's making sure that the value being entered by the user is a length, rather than, say, text or something. Assigning it to a value called definition.radius. And then right at the end here is these length bounds. And this is, there is a number of built-in ranges of numbers that you can use to limit the input from the user. They have a maximum, a minimum, and a default value. There are quite a lot of them, and you can create your own. So if you can't remember what they are, if you just type in bounds, then it will list them all. You can see there is quite a few of them. Okay, but the one we're after is blend bounds, which is the same value which the fillet command uses, which probably makes sense because we're doing fillets. So now when I commit that and run the feature, you can see the default now is 5. Okay, and then if we try to make it 0, it's going to complain, whereas the length bounds wouldn't complain. Excuse me. Okay, and we'll go and add that feature in there. I hope I haven't lost anybody so far. Now, one of the main things about FeatureScript is that it behaves like a built-in standard function feature, of Onshape. Of course, you could have done something like this in a traditional CAD system like SolidWorks, Inventor, or any of those products by creating a macro. Okay, that's no big deal. But what difference is here that the feature will rebuild because of this query. The feature will rebuild to let you to adapt to changes in geometry. So, for example, if I go back to the feature which defines this pocket, and I just make turn these circles from construction to regular, so it cuts out the hole, you can see that feature will adapt to fillet all the edges in that pocket. If that was a macro, that wouldn't have happened because all that would have done would have created a number of fillet commands to actually produce the same result. So you wouldn't necessarily get the same level of update. There's a question there: is the blend bounds referring to the geometry on the fly? No, they're not. So these are just default values. So it's not going to interrogate the model and give you a value. It is actually possible to do that, but it's beyond the scope of this exercise. Okay. Okay, what I'm going to do next is to adapt this script a little bit more to make it a little bit more a different, bigger feature. And also, like I say, I'm going to make some mistakes on purpose to see what goes on when we try to troubleshoot. But before I do that, let me just go back to my slide deck and talk about queries. Okay, so like I mentioned, so a query is what gives the Onshape the associativity inside a model. So it can adapt to changes, to features further up the tree. And it basically does this by, when it selects something, it's a criteria for finding something in the model. So it isn't actually the edges. When I mentioned that each edge has its own unique ID, if you imagine if the query stored that unique ID and then somebody changed it, however they changed that number by modifying something, then suddenly your feature would fail because now that ID no longer exists. So the query gets around that by using a search criteria to find what it's looking for. So it doesn't matter if something changes the ID numbers of features up the tree, the query will sort that out for you. So that is really where the power of the query comes in. Okay, like I said, there are specific queries to help you find things faster. We saw those in the list. It's probably 50 or so of them. Queries can be combined, so you can chain them together to get to be able to filter things in more detail. But at the end of the day, a query, like I say, is a criteria for finding things. If you actually want to get at the things that are in the query, then you use this thing called evaluate query. And what evaluate query will give you back an array of all the queries that were in your original query, if that makes sense. We'll look at it in a little bit more detail in a moment. But my little mantra, which I like to say, is that if you can master the query, then you've essentially mastered FeatureScript, because it takes a little bit to get your head around it, but once you understand it, you'll be flying with FeatureScript. So let's go back to this guy and make a couple of modifications. So let's call this. I'm going to change the name of it. I'm going to call it Fillet All. I'll leave that as my fillet. And this time, what I'm going to look for is to fillet all the convex edges, for example. So I'm going to say on the part. So first of all, I want to look for the part itself. So let's say part part to fillet is the prompt. This time I'm going to look for, and so this is an enumerated value. So you can see there's different entity types. So again, if you go back and delete the decimal point, the period there, and then it'll give you the options, and you can scroll up and down them and press enter to get that. So that's basically saying only let the user select a body rather than a sketch or rather than a face or a vertex or an edge. Now, a body can be a number of things. A body is actually a face, a curve, a surface, a solid. So really you want to be a little bit more specific. So what you can do is combine these things. And I'm going to go to use body type. And the body type is solid. So that's basically saying select a solid, let the user select a solid body, but it has to be solid. It can't be a sheet, which is a surface, a wire, which is a curve, or a point, or a make connector. Okay, max number of pixel 1 is good. And let's just change the name of that so they don't get confused. So that's called the part we're looking for. And we'll leave radius as it is. Okay, now this time, what we want to do is find the edges. So let's go find the edges in this model. Now, again, we're going to go for query. Like I said, there is a lot of things in here. We could query everything and then filter that by edge, but that will get you all the parts in your part studio. So and basically ignore what the user has selected. So we really want to be a little bit more selective about what we create, about what we choose. And owned by body is a good one to do. So you can see here, this particular query will find all the vertices or any other entity type which belongs to a body. So let's go ahead and use that one. The body that it's looking for is the one that the user selected. So again, we're just getting the query out of the definition map and place it in here. And the type here is edge. Okay. Now we've got edges. So that says faces there, so that should be edges. Radius is fine. That's it, we're done. So let's go ahead and commit that. Okay. Now the reason this feature's failed now is because, of course, I edited the original. Really, I should have created a new one. But if I edit, I can edit this now. Just double click to edit it. It's part to fill it. Click that, and you'll see that it's. I'm sorry, it's there selected all the edges on the model. Okay, so select the part. It's created all the edges. Okay, now let's just do that a little bit further. Now we want to find just the convex edges. Now, in order to find something like whether an edge is convex or concave, or whether it's tangent to something else, then you need to evaluate the query. And what this does, it gives you a little bit more information about the entity that the query has found. So we'll do that by going, what should we call it? Actually, let's call it, we can always change it. Fillet edges, and the query we're going to, we're going to use evaluate query. Context, like I say, is the part studio we mentioned previously, and the query is this variable edges. So essentially what this is doing is taking the query for all the edges in the part and returning an array of individual queries for these. Okay. Now what we can do something like, we can do like a for loop. So we can go looking for each individual edge in, in fact, let's just call that edges. No, beg your pardon. Okay, so that's basically going to loop through this array of individual queries. And let's just do this. So we go ev is all the evaluate functions. So we can evaluate edge convexity is one of them. Okay. And just to make it a little bit clearer to read, I'm just going to put this all into one line. Okay, so that's testing the edge convexity. I'm not going to say, okay, what edge convexity type is convex. So that's basically saying if the edge is convex, then what we're going to do? Well, what we'll do is we'll create a second array of edges to fill it. So I'll need to do that up here. So let's call that convex edges. I'll just create an empty array. And then down here, I will add its edge. So essentially what that's doing there is it's created an empty array up here. Then it's going to loop through all the queries. And if edge is convex, it's going to add it to this this array. And then when we come down to the op fillet, what it's looking for is one query here rather than an array of queries. So one way to do that is to use, if you use QUnion, it basically combines the array of queries back into one. So these are just little subtleties that you'll just have to learn and just use each time you do that. So let's see how we get on with that. Okay, so you see that's updated for me. So you can see these convex edges have not been filleted. Now the nice thing about this as well is that because this is live, it's live editing. If if I come in here and edit this, and let's make that concave, and commit. When I go back to here, okay, you can see it's picked the concave edges as well. So you can, if you right click on a tab and say open a new browser tab, you can see you can have both browser tabs, both browser windows open at the same time. So as you're modifying code, your model is updating for you automatically. So it's a very nice way to be able to work out exactly what's going on. Okay, let me just undo that. Okay, that's great. So here's where I'm going to deliberately do something wrong. So you could argue that, okay, we've got the convex edges. Let's go for the concave edges. So let's call that concave edges and create an empty array. We'll have another radius up here. Let's do a second one. Let's call that concave radius and convex radius. Let's just change those as well. Hope you're following along. I know it's not terribly exciting watching somebody write code, but there we. So we created those values there. The question there for a radius value, can a specific default be set? You would have to generate your own. This thing here called blend bounds. You would have to generate your own bound condition, which you can do in the same script. It's not difficult to do. If you're looking at some of those sample scripts like the spur gear or the screw boss, you'll see examples of that. And in fact, if you go to, well, I will talk about the learning resources in a moment. A nice little button to use here as well as this Format Feature Studio, which kind of tidies up your code for you as you go. Okay, so let me just, so that's going to be convex radius. And let me just check that everything's working as it was before. Yeah, that's working. Okay, so I've not broken anything. Okay, so you might think, okay, well, therefore I've created an array of convex edges. Let's just create another array of concave edges. So let me just copy and paste this. And let's go for concave and concave. Oops. Concave. Concave. And just fillet those. Just copy and paste that. And this is going to be fillet 2. Please bear in mind when you create a feature, what you'll see here, there's an ID. So this is the ID of the actual feature. But if you're doing any sub operations inside the feature, like doing multiple fillet operations, multiple extrude operations, each thing needs to have a unique ID. And you basically do that by just doing a plus symbol plus some text. Okay, so this is fillet 1, fillet 2, and they have to be unique. But Onshape will let you know if you've made a mistake there. Okay, let's just put this over here. Oh, concave radius. All right. Okay, so you might be excused for thinking that will work. Okay, and I'll explain why it doesn't in a moment. So when it comes to here, we're now saying select edges or faces to fillet. Well, I did. So what's going on? if you press this button up the top right here, the FeatureScript notices, you can get a little bit more information. So it's telling me here that op fillet failed with the fillet select edges. It also tells me at line 36 is where it failed. So if I can double click on that, it'll take you directly to the code. So it's saying that failed, but it's not really giving me much information. You can do things like comment things out. So if on Mac, if you press Command and /, it will comment everything out. I assume on Windows, it's either Control or Alt / one of the two will do the same sort of thing. So as you are troubleshooting things, it's a good idea to comment out bits of code, because Onshape, when it's running, it won't create this fillet and then fail to create this one. If there's a failure at all in the feature, everything will fail. So it can be a little bit tricky to debug. And the reason why it's tricky to debug is because everything's live. It's like a live, it's not something you can step through. Everything is live. So if I come back to this feature, I can say that was fine. Okay, what went wrong? All right, well, what you can do is use a very useful feature called Debug. And what Debug will do, it'll give you some extra information in this panel at the bottom here. So let's do, we're going to look, sorry, this one here, the concave edges. So it's basically saying, show me what you think are the concave edges in that model. Let's go ahead and commit. Query resolves to nothing. What? That makes no sense. What do you mean it resolves to nothing? So it's basically saying that this list of things here basically didn't do anything. And the reason being, it's a little bit difficult to get your head around, but the reason being is that a query is always live. So for example, if once I filleted this part, the query changed because first of all we were looking for all the edges in the part. Okay, once we add a fillet, we're still picking up the edges, but we're picking up the tangent edges of the fillet. So this fillets down here will then fail because, of course, you can't fillet a tangent edge. You just can't do it. So that is the reason why it is failing. So really, you need to find a way to get around this. Okay, and one way you can do that is to just run the query again. Okay, which is a little bit time consuming. So after, let me just take this out here. I'm just going to put it down here and comment it out so I can copy and paste that later. So I don't need this anymore. So there's my first fillet. So I'd have to do this in two operations essentially. So query all the edges, find all the convex edges, fillet it, and then run the query again. But what you can do is, rather than run the whole query again, which suddenly, especially if you've filleted, you're going to go from 30 edges to 300 edges, something like that. You're going to very quickly slow down your model. So one thing you can do is to get the result of a previous feature operation. Okay, so let's call this new fillet edges, and we're going to query something that was created by something else. Okay, so if I query fillet one, so that's the unique identifier. So I'm basically saying and edge. So essentially what this is saying here is find all the edges that were generated by these fillets. Okay, so those are all the fillets, all the fillet tangent edges will be now created in a new query. Now the original query is still pointing to all the edges, including the tangent fillet edges. So what we want is the difference between the two. So let's do what should we call this? Let's just call it new edges. Okay, and then you can use something like Q subtraction. So this is basically saying, give me the difference between two queries. So basically it's saying the full query, which is all the edges in the model, I want to take away these here. So basically that will give me the difference, or basically the edges that are left over. Okay, now that means now that that new edges is a lot smaller, and you're not doing too much work in your feature to fix it. So let's just go ahead and, in fact, let me just copy and paste that. Just repeat this again. There's a bit of copy and pasting here. What you might actually do is actually break this out into a function. So I'm going to go. Now I'm going to test the edges in this new smaller list of edges. Check for concave, and that's going to be concave, fillet 2, concave, and concave. All right, provided I've not made no mistakes, that should do it. So if I go ahead and commit that now, okay, still didn't like that. Why not? Edges query. Oh, that's absolutely right. Okay, so that's then give me an error condition there saying that this feature edge convexity here failed. Why did it fail? Because it's looking for a query, an individual query, that is an edge, whereas I actually sent it the full query, which was all the edges. So again, you need to evaluate that query, and actually what I'll do is just put it all in line. So there's no need to put them out as separate variables if you don't want to. So basically it's now saying, give me the difference between all the edges filleted by the first operation, and evaluate them for me. So now when I commit, fingers crossed, no, what have I done now? Fillet failed. What have I done there? Let me just double check that. Okay, that's working. Ah, yes, I know why. The reason that failed is because those edges are now, in fact, I'll just show you why it failed. And obviously I did test this before I came online, so I've worked out why it failed. And the reason it failed, if I turn that so you can see all the fillets correctly, is that it's trying to fillet these individual edges and miss these edges off, which have just been added. So that is why it's failing. So I can fix that very easily just by adding a new parameter in there, which is tangent propagation true. Commit, blank. There you go. All right, so there you go. So now when you can see I can now modify the fillets for both individually, and if that's something that you do all the time, like say you can if you make if you make changes to this. So if I go ahead and in fact, let's just edit that original sketch, and let's just blow a hole through the center of there or something like that, and then roll that to the end. Okay, why did that fail? Oh, it's just the fillet size. That's the reason why it failed. Okay, so someone's asking a question here. Yeah, so it's saying about the edges have been found and stored in the for loop prior to filleting. The first fillet is made, changes the edge ID, so the second fillet will fail. Yes, but essentially your list, as soon as you add the first fillet, suddenly the list here will be will change. So then when it's evaluated in this fillet edges, you're going to get a different result because of that fillet went in there. So these are kind of what I'm showing you here is something which you don't really come across until you start digging into FeatureScript in more detail. So these are the kind of things that you might trip up on. Is just remember that a query is always live. So if during your feature you are modifying something like adding a fillet, adding an extrude, chances are the query will no longer be valid. So you should then reevaluate the query or do something different. So whereas what I did there, of course, was then keep the original query but remove the edges that were generated by that fillet to get me a smaller thing. Because if I hadn't have done that, what you can do, which is a really nice feature, is we have a profiler here. So go ahead and profile that, and you can see to run that feature it took 85 milliseconds. Now, if I hadn't have done this here, then that will be a lot worse. So, for example, if I change that back to just being something like this, so querying all the edges, bearing in mind this edge now includes all the edges from the fillet, and commit that. Oh, actually, that came out all right. That came out all right. So obviously, there's not as many edges in there as I thought. But you know, the way I did it there would be the correct way to do that. And the nice thing about this the profiler is if you've got a heavy feature which is doing a lot of calculation, doing a lot of geometry building, then it will give you the timings for each individual feature. So if you've got something which is running slow, you might well then want to look ways of to break that up and to make it a little bit faster. Now, what you'll see is, just before we wrap up, because we're almost out of time, what you'll see here is that if you hover over something, it will give you a brief version of what is in the help documentation. And because if you go like that, you'll see it disappears. If you hold down Shift, you can, if you hold down Shift, you can move your cursor over it, and then you can read it in more detail. You can also see that if you hold down Alt or Option on Mac, you'll see a little arrow. If you click on that, what this will actually do is open the source code for that feature. So if you want to know how the op fillet works, or you want to see why perhaps something's failing, or perhaps look at some of the extra parameters that are available, this will take you straight to the feature from the standard Onshape library. So this is the regular fillet command that you'll find in Onshape, and like I say, it's a little bit more difficult to decipher what's going on, but all that information's in there. One last thing you should be aware of is that to get to the documentation, you could do it from the web page, or you can do it directly from inside Onshape. If you go to the help menu in the top right, there is FeatureScript documentation. So you can click on that. It will open the FeatureScript documentation. In here, you have an overview, tutorials. In fact, if you click on the tutorials, you can go step by step and build this feature. So there's a video of it. It goes through a lot of the things I spoke about today. There's also an example of doing sketching, because you can build your own sketches and add constraints and so on. You know, there's a lot of stuff in there. There's an example of building your own default values. So here it's basically saying bump height bounds. These are the in the different units available. These are the max, the min, and the one in the value there is the default. So if you want to modify your own default, you could add that to the bottom of your script. If you go to standard library documentation on the left here, then this is all the features, all the queries, the evaluates, the op features, the math, everything is in here. Now, typically what I would do, if I'm going to build a feature from scratch, typically what I would do, I would model it. So I would, to see if it's actually possible. So I'd perhaps go ahead, model this thing manually, and then trying to work out how's the best way to do it, because you might have to think a little bit laterally to get the most efficient way of actually building the feature. Question here, how long does it take to appreciate the full scope of the FeatureScript API? Thing is, it's changing as well. Every 3 weeks when we release Onshape, the FeatureScript changes as well. I mean, I've been doing it around about a year now, and I've fit, apart from like the last couple of days, I've not touched it for a while, so it did take me a little bit to get back into it. But you can, if you follow all this documentation, if I'm thinking, okay, what's the best way to do this? Well, I'm looking for a query. So let's go to query, and I'm just going to look through these types of queries. What sort of queries is there? If I were to find that QCap entity, for example, will find the top and bottom face of an extrude feature. So it's very useful. Lots of different queries, lots of different geometry operations. Everything in here is worth a read through. So we're out of time. I will hang around for a few minutes to answer some more questions. I'll do those kind of offline, but you can still answer the questions. and I hope this has been really useful. I know it can be a little bit tricky watching somebody write code, but hopefully I've managed to convey some of the more nuances of the query and the evaluate and the fillets and so on. Okay, and with that, I would like to thank you for attending, and please get feature scripting. That's my email address and my Twitter handle if you want to get in touch. You can also find me on the forum very regularly. You'll find on there as well if you want to, if you develop a feature and you want to share it with everybody, please contact me through the forum and we can get it up on the main FeatureScript website. Okay, that's it. Thanks very much and have a nice day.